time is the fourth dimension, but it have a direction? How did Einstein describe the distinction between past, present and future? In this episode we will take a closer look at the concept of time near a black hole, as we go through the enigmatic world of black holes and the idea of time. Welcome back to my channel. In theory, you will be correct to say that if you remain far outside a black hole's event horizon, the time passes normally for you and for any other observers in the same inertial frame with you. But near a black hole, the passage of time is significantly altered. Time it passes at normal rate for you but is deeply subjective. Time moves more slowly near black holes. If you spend time there, the time on Earth will pass quickly while it moves slowly for you. Therefore, if you spend a year hanging out close to a black hole and subsequently return to Earth, the time may have passed by 10 years or even 1,000 years for a faraway observer. We are speaking in fact about space, about spatial coordinates near a black hole, the region where if you can stay safe enough, just enough so not to be pulled in by the gravity, rather normal space as far as you are concerned, but dramatically altered from the time point of view. Hovering above the black hole, staying in the same position, you are moving through time at such a fast rate, that by the time you came back to normal flat space from the point of view of a faraway observer, hundreds of years, even thousands, would have passed. This is kind of extreme even if we have the technology to fly near a black hole. It is literally a time machine into the future, but why do we need to go and stay there in the first place? Can a flyby will actually be enough? The voyage I am describing can appear to be one across space. You travel to the black hole from Earth and then return. However, it's also a journey through time, since when you enter the black hole neighborhood and then emerge back to flat space, the time will not have passed as you would have anticipated. On Earth, there will be considerably more of it. Our perception of time and space has been completely transformed by Einstein's theory of relativity. This theory contends that time is relative and dependent on the velocity and gravitational field of the observer, rather than being totally universal. Along with the three dimensions of space, time is considered to be the fourth dimension. The idea that time has a direction is still up for controversy among physicists. Some think that time goes in one direction, the arrow of time, from the past to the future. Others contend that time is symmetric and that the universe's starting conditions are where the arrow of time originates. A radically different perspective on time is provided by Einstein's theory of relativity, in which we consider each moment to be equally real to the others. It's not merely that the past is history and the present is actuality. Every moment is as real as every other moment in the past, and the future is still to come. Future and present are real. The boundary between the past, present, and future is merely an illusion, no matter how persistent, and this is what inspired Einstein's own poetic depiction. A friend and a collaborator of Albert Einstein, Hermann Minkowski, defined the universe as a 4D manifold, a construct that have three spatial dimensions plus time, so 4 dimensions, the so-called 4D spacetime or Minkowski space, and this is used in mathematical physics and special relativity. It combines three-dimensional Euclidean space and time into a 4-dimensional structure, where the interval of spacetime that exists between any two events is not dependent on the inertial frame of reference. We are so accustomed to the way that physical events in the world appear to always develop in one temporal orientation. In reality, there is an innate belief that time has a direction, or what we refer to as an arrow. As one of our favorite canonical instances, if you drop an egg, it splatters but it never unsplatters. Time have an arrow and it's deeply connected to entropy. We are still yet to see someone jumping out of the water and landing on the diving board, but if someone dives off a diving board, they fall into the water. This is significant because the reason you laugh when you see reverse run movies is because it contradicts everything you know to be true about how time works. The interesting thing is that, when you look at how the rules of physics are currently structured, they all follow the correct interpretation. But all physical rules share the property of treating the past and the present equally and symmetrically. The Feynman diagram shows that the time is reversible. Particle physics don't care about time. For an electron-photon interaction, the time can go in either directions. Therefore, any sequence of events that can develop in one direction are permitted under the rules of physics when we analyze the laws of motion as physicists. In reality, there is an algorithm that guarantees that all it takes to undo any physical unfolding is to just reverse the motions of the particles involved. Near black holes, where there is a strong gravitational pull that slows time, the implications of time's relativity are most apparent. Time slows down when you get closer to a black hole because of the increasing gravitational pull. Understanding the nature of time is essential to comprehending the behavior of black holes, and the effects they have on their surroundings, like close to a black hole's event horizon. In this episode we will not dig deeper of what the space and time behave behind the horizon, where space and time switch roles. Space becomes a time-like dimension and vice versa. If you could survive these extreme conditions, near a black hole, you might be able to experience some of the most extreme phenomena in the universe. Science fiction frequently depicts the fact of leaving Earth and going near a black hole, but this is not just a theoretical possibility. The intense gravitational fields would have a devastating physical impact on your body. You may be stretched to the point of being torn apart by the gravity acting differently on your head and feet. If you are near a waterfall and paddling a kayak, you can escape if you can paddle more quickly than the water is flowing into the cascade. However, if you can't paddle more quickly than the water is moving, you will be doomed to plunge down the drain. The analogy is that space itself teeters on the brink of a black hole. The speed at which space falls over the edge of a black hole is equivalent to the speed of light and resembles a waterfall of space. Since nothing could move more quickly than light, you are doomed if you are that close to a black hole. You might as well paddle directly in its direction and take a joyride inside its mouth. In some ways, the edge of a black hole is like a waterfall. It's rushing over the brink at a faster rate than you could ever swim to escape, or, in the case of a black hole, faster than the speed of light. You can't paddle upstream because nothing can go faster than the speed of light. Additionally, if you are unable to paddle upstream in order to escape the black hole, you will inevitably fall into it. You might be able to witness some of the universe's most extreme occurrences if you can endure these harsh conditions. Although for a really massive black hole you should be fine at least when crossing the horizon, but the gravitational pull of a black hole gets greater as you go closer into the deeps. Time is not a constant of nature like the speed of light, which is what causes it to slow down. Time is influenced not only by your movement but also by the gravitational field you are in. However, if you were to travel close to a black hole's edge, where gravity is much stronger, the time warp caused by being closer to the black hole compared to being farther away from it could lead to a sizable time warp, or difference in time, between the clocks that are ticking at those various locations. Black holes continue to intrigue and inspire people, both in science and in the general public, despite their mysterious and frequently baffling characteristics. While the thought of traveling to a black hole may still be considered science fiction, developments in our knowledge of black holes and the nature of time are opening up new possibilities for research and providing fresh insights into how the universe functions. Who knows what other surreal discoveries may be in store for us in the future? Please join me in the next episode when we will discover other interesting concepts of the modern physics. Thank you for watching.